These molecules where there is a double bond are called alkenes. These are unsaturated hydrocarbons which contain at least one carbon-carbon double bond. There are also unsaturated hydrocarbons that contain a carbon-carbon triple bond, and these are called as alkynes. One of the most common known alkyne is ethyne with a molecular formula C2H2. Let us draw structural formula and electron dot for ethyne. I have one carbon-carbon single bond. There are two carbon-hydrogen bonds present. So each of the carbons is bonded with one hydrogen each. Now each carbon has 4 electrons around it. It needs 8 electrons. Another carbon needs to share electrons such that it forms a triple bond. With the triple bond, carbon has the octave complete. Thus, the alkyne have a carbon-carbon triple bond in it. We looked at alkenes which have hydrocarbons that contain carbon and hydrogen and only single bonds. In order to explore isomers of various compounds, let us think of the possible structures of the compound that has the molecular formula C4H10. This is butane. We talked about how we can draw a butane molecule. 4 carbons are in a straight line and all the hydrogen bonds are formed in such a way that the valence is satisfied. Remember, there is one more way to draw this carbon chain. Instead of putting all carbons in a straight line, I can put 3 carbons next to each other, and one of the carbons can form a bond within the middle carbon. This can be called as branched chain. The first one was a straight chain. These two molecules of butane that have the same molecular formula but different structural formula are isomeric compounds with the formula C4H10. The phenomenon in which compounds having different structural formula and same molecular formula is called as structural isomerism. The number of carbon compounds increases due to the isomerism observed in carbon compounds. So far, we have looked at molecules that have just carbon and hydrogen. Remember, we have other compounds such as halogens, oxygen, nitrogen, sulfur, and so on. All these elements other than carbon and hydrogen are known as heteroatoms. Whenever we have a particular arrangement of heteroatoms or a particular arrangement of heteroatoms and carbon and hydrogen, this specific arrangement gives rise to specific chemical properties. Irrespective of whether there are 1, 2 or more carbons, if you have the specific arrangement of elements, these will give specific chemical properties. They acquire specific chemical properties due to presence of certain functional groups. You must have seen some of these. For example, if you have the structural formula of OH, typically gives rise to a functional group called as alcohol. Alcohols, methanol, ethanol, propanol are very commonly used, have common chemical properties. They only react in a particular or a defined fashion.